Hi students, today we are going to discuss the last synthesis technique which has been mentioned as a part of our syllabus in the module Growth Techniques of Nanomaterials, that is electrodeposition. Electrodeposition is a method which is quite familiar to you. It is that process in which an electric current is passed through a non-polar liquid by applying an electric potential between two electrodes. So I'll show you a figure. So this is the process. It is a liquid based deposition process where an electric current is passed through some kind of non-polar solvent by applying an electric potential. How is the electric current passed through the nonpolar liquid? By applying an electric potential between two electrodes. So this is the anode and this is the cathode. The liquid ionizes in this process, and depending on their charge, the ions move towards the respective electrodes. That is, positive ions move towards the cathode and the negative ions move towards the anode, and they deposit on each electrode. By suitable arrangement and choice of the preferred substrates on the electrodes, thin films of desired materials can be coated on the substrate. We have to suitably arrange the substrates on the electrode so that the film that we want to coat on the substrate can be formed. Now, this technique has been used since a long time for electroplating materials. You must be familiar with the process of electroplating. So, this electrodeposition is the technique which is used in electroplating. The function of electroplating, or the objective of electroplating, is to coat an electrically conductive material on the surface of a material which is not conducting. കണ്ടക്റ്റിംഗ് ആയ ഒരു മെറ്റീരിയലിനെ തീരെ കണ്ടക്റ്റിംഗ് അല്ലാത്തൊരു മെറ്റീരിയലിനെ മുകളിൽ കോട്ട് ചെയ്യാനും, പിന്നെ ഇലക്ട്രോപ്ലേറ്റിംഗ് ഇസ് ഓൾസോ യൂസ് ഫോർ ബിൽഡിംഗ് അപ്പ് ദ തിക്നെസ് ഓഫ് അണ്ടർസൈസ്ഡ് പാർട്സ്. സപ്പോസ് യു ഹാവ് a highly thin or fragile part, so to increase its thickness, വളരെ കട്ടി കുറഞ്ഞ ഒരു ഭാഗമുണ്ടെങ്കിൽ അതിൻ്റെ കട്ടി കൂട്ടാനും ഇലക്ട്രോപ്ലേറ്റിംഗ് എന്ന് പറയുന്ന സംവിധാനം ഉപയോഗിക്കാം. ആൻഡ് ഇലക്ട്രോപ്ലേറ്റിംഗ് ഈസ് ബേസ്ഡ് ഓൺ ദിസ് ഇലക്ട്രോ ഡെപ്പോസിഷൻ പ്രോസസ്. ഓക്കെ, സോ this technique of electrodeposition has been used since a very long time for the process of electroplating. Okay, next, ceramic materials or electrodeposition method can be used for ceramic processes, that is for the formation of ceramic films, etc. So it involves two processes. One is electrophoretic deposition, that is ceramic processing using electrodeposition involves two processes. One is electrophoretic deposition, this one, electrophoretic deposition, EPD, in which the suspension of ceramic materials is used, and electrolytic deposition, in which metal salt solutions are used. So this figure shows electrophoretic deposition, in which ceramic materials are used, or ceramic particles are used in the suspension, and the second one in which metal salt solutions are used, that is electrolytic deposition. Now, the method of electrodeposition is also useful in nanofabrication. It is based on Faraday's laws, that is, the process of electrodeposition is based on Faraday's laws. So, by carefully controlling the number of charged particles transferred to the substrate, that is, by controlling the current and the time and any other factors involved in consuming current, like impurities, the total amount of deposited material can be precisely controlled. So, ഇവിടെ പറയുന്നത് electrodeposition can be used in nanofabrication. electrodeposition obeys Faraday's law. So, by carefully controlling the number of charge particle transferred to the substrate, uh, so if you have an electrode and you are controlling the number of charge particles that are transferred to a particular substrate, then so you have an electrode here, and by controlling the number of charge particles transferred to the substrate, how can you control the number of charge particles? By controlling the current, by controlling the time of deposition, and by controlling any other factor that uh, consumes current like the presence of impurities. If you control factors like the amount of current, the deposition time, and factors like impurities which consume the current, the amount of deposited material can be carefully controlled. Now, another important application of electrodeposition process is the fabrication of self-assembled nanoporous materials like anodic aluminum oxide, porous silicon, etc. And so this is the next important application of electrodeposition. That is, you take a material as the anode, and as a part of the deposition process, this anode becomes porous, or pores are created in the anode. This method is used for the generation of anodic aluminum oxide, porous silicon, etc. So the anode becomes porous as the process of electrodeposition progresses. And these porous anodes can be, or these porous nanoporous matrices can be used for the growth of nanoparticles, nanorods, nanowires, etc. That is, these nanoporous anodes, or the nanoporous materials that you synthesize, can be used for the growth of nanorods, nanowires, other nanoparticles, etc. That is, um, they act as nanoporous matrices. This process is called anodization, as the pores are formed in the anode of the electrodeposition cell. This is an important point. This process, that is creation of pores in the anodes by the process of electrodeposition, is called anodization, as the pores are formed in the anode of the electrodeposition cell. And this technique is highly advantageous as it offers a rigid control of the film thickness, and it can be used to control the uniformity and deposition rate. It has low equipment cost, and it is also suitable for forming uniform films on substrates of complicated shape. Then it is used for the impregnation of porous substrates. It is used for the deposition on selected areas of the substrate. In all these ways, this technique is highly advantageous. So, once again, we'll revise electrodeposition. Electrodeposition means it is a liquid based deposition process in which an electric current is passed through a non-polar solution by applying an electric potential between a cathode and an anode. In this process, the liquid ionizes, and the ions formed, depending on their charge, they will move to their respective electrodes, that is, positive ions towards the negative electrode and the negative ions towards the positive electrode. And by suitable arrangement of the substrate, you arrange the substrate at some position so that these positive ions will deposit on the substrate and it will coat on the substrate to form thin film structures. Now, this process of electrodeposition has been used since a very long time for the process of electroplating. In the process of electroplating, for coating an electrically conductive material on a non-conducting one, and in electroplating, it is also used for increasing the thickness of undersized parts. Now, this process electrodeposition is especially useful in nanofabrication because it follows the process. I mean, electrodeposition is based on Faraday's laws. So, by carefully controlling the current, deposition time, and factors which consume current like impurities, the amount of deposited material can be carefully controlled. Electrodeposition is also used for ceramic synthesis, that is, it is used for forming ceramic films. Here, two processes can be followed. One is electrophoretic deposition, in which suspensions of ceramic particles are used, and electrolytic deposition, in which metal salt solutions are used. Another important application of electrodeposition is anodization. Anodization means forming um, porous nanopores in the anodes. That is, it is a fabrication of self-assembled nanoporous materials that is, you grow nanoporous materials like anodic aluminum oxide and porous silicon. What is the use of such porous matrices? They are used for the growth of nanorods, nanowires, and other nanoparticles. And this process is called anodization, as pores are formed in the anode. And lastly, we discuss the advantages of this process, that this technique, that is electrodeposition technique, that is, you have rigid control on the film thickness. There is a control over the uniformity and deposition rate. This process involves low equipment cost, and it is also suited for forming films on substrates having complicated shape. It is used for the impregnation of porous substrates, and it is used in the deposition on selected areas of the substrate. So I hope the process of electrodeposition is clear to all of you. If you have any doubts, please do contact. Thank you.